Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 9, Problem Solving When the Percent Changes. Classwork, Example 1. The amount of money Tom has is 75% of Sally's amount of money. So, if Sally has $100, then Tom has 75% of that, or 75. But then it says after Sally spent 120 and Tom saved all his money, Tom's amount of money is 50% more. So Tom's amount didn't change. So obviously Sally doesn't have 100, but I was just giving you this example. So if Sally had 200 and Tom had 75% of 200 is 150. So Tom would have $150. I'm just giving an example here. This is mental math, just trying to figure out what's going on. But then it says Sally spends $120, so now she's down to 80 bucks. But Tom saved all his money, so he still has 150. Well, 80 is a lot more than 50%. It would take, or 150 is a lot more than 50% more than 80. 50% of 80 is 40, that'd be 120. So this estimate's not right, but you understand what's going on here. Sally had some money, Tom had 75% of that. She spent $120, and now she has 50% less than him. We want to find out what those values are. So since we're talking about 50% and 75%, we can use increments. So it says to use a visual model and percent line to solve the problem. So if I have two people, so I'm going to use a table with one square representing Sally, one representing Tommy, and that would be 25%, 50%, 75%, and 100%. So here is my table I'm going to use. And let me just move it up. Oops. Okay, so I've done two models here. We want a before and we want an after. So let's do before in red. This is before. And we'll do the after in green. All right, so this is 0%. This is 25%. This is 50%. And this is 75%. And this is 100%. We're talking about two different people. So we'll put Tom here and Sally here. We're talking about their money. Well, the first sentence says that at the beginning, Tom has 75% of Sally's money. So I will shade in 75% for Tom and 100% for Sally. Okay, so I shade that, and shade that. That will represent 75%. Sally's money is 100%. So I want to shade all of these, and I'll use a darker, maybe this green. And I'm going to shade all of those for 100%. Okay, so there's the model. There's the percent model representing Tommy and Sally's money. He has 75% of what she has. Now after, it says, after Sally spent $120. So Sally's money is still 100%. We still want to consider hers 100%. But Tommy has 50% more than her now, so that would be 150%. So my percent line down here is going to be, let me change colors to something else. Let's use red here. This is going to be 0%, of course. But this isn't going to be 25 here because we're now dealing with 100% and 50%. We can do 50% increments. So let's make this 50%. This 100%. And this 150%. and this 200%. Okay, so now we're going to shade these in. Well, after, I'll put Tommy on top again, Tom first, and then Sally, I'll write down here. So Tom's money is now 50% more than Sally's. So Sally's money is still going to be 100%. Her money, we're going to consider her money as being 100%. So let me do her 100% first. And this time we'll use red, I suppose. Okay, so Sally still has 100%, like so. But Tommy is 150% of hers. So I will use red, but a different shade of red. Let's go lighter. About like that. Okay. And there. And one more time. There. Okay. So now here is a representation of percentages. So recapping this, Tom had 75% of Sally's, but now he's got 150% of Sally's, and that amount stayed the same. So we want to know what this value is, and her value changed. Her value went from 100% down to still 100%, the equal amount, but it's decreased. So his value stayed the same, but went from 75 to 150%. So the key here is, how much did Sally spend? Well, she spent 120. Sally had 4 squares, so now she's only got 2 squares. So if she lost $120 in spending and it resulted in 2 squares, then each square is worth $60. Okay, does that make sense, everybody? Hopefully. So if these are all $60, Tom had 6 times 3 are $180. Not percent, dollars. Tom had $180. He still has $180. 60 times 3 is still $180. Sally had $240. But now she's only got $120. So she spent 120, spent half of her money. So she went from 240 down to 120. He stayed at 180. So 180 is 75% of 240, but 180 is 150% of 120. So the answer is, what does the question ask? How much money did each have at the beginning? Well, there's our answer. She had $240, he had 180. Okay, let's try this one more time. Example 2 says, Erin and Sasha went to a candy shop. Sasha bought 50% more candy than Erin. After Erin bought 8 more candies, Sasha had 20% more. So the key here is we have a 20% value, we have a 50% value. So our first table is going to be in increments of 50%, and our second table is going to be in increments of 20. So Erin and Sasha went to the candy shop. She bought 50% more, so we want Erin to be 100%. So 50% more than that's 150. And if I do 50% increments, then I'm going to have a table. Now, Sasha and Erin, 2 people. And if I do 50% increments, so I need 50, 100, and 150, that's only 3. So if I make a table of 3s like this, let me put it right there, and then I will make this 0%, 50%, 100%, and 150%. And we're talking about Erin and Sasha. Okay, this is before, and now we need to do an after. So an after is still going to be Erin and Sasha, but we're going to do 20% increments now. So we have 20, 40, 60, 80, 100% would represent somebody's amount, but the other one has 20% more, so I'll go out 2 more. So now I use this table and bring it down here. I'm going to make these the same length, close to the same as I can. So I'll start that one there, and I'll make them the same length, like so. Okay, so now we're going to have 0, 20, 40, 60, 80, 100%, and 120%, and 140%. One, two, three, four, five, 6. I have 1 too many. I only want to go out to 120. We're not going to 140. Okay, so now I fix that. 20, 40, 60, 80, 100, 120%. Now when I shade this in, Erin and Sasha went to a candy shop. Sasha bought 50% more candies than Erin. So Erin is going to be 100%. So I will choose these same colors so it'll be quicker. So Erin will be 100%. Right there. That's Erin. Sasha bought 50% more candies than Erin. Okay, so there's our first representation. After Erin bought 8 more candies, so now Erin, who had 100%, after she bought 8 more candies, Sasha had 20% more. So Erin added 8 candies to get to the 100%. So what's going to happen here is, let's use red here. So she already had the 100%. Okay, so the 80%, so this new portion right here, I'll do a little bit lighter like pink. Okay, that is going to represent the 8 candies that she bought. That will give us 100% again. So this is 8 candies. Okay, so she now still has 100%. We're still representing Erin as being the 100%er. And she bought 8 more candies, so now she's still 100%, but now it's 8 more candies. And with those 8 more candies, Sasha has 20% more. So now Sasha, all of these are going to be shaded, so just to save time, I'll do it behind. Okay, so there's our visual model complete. So before Erin had 100%, Sasha had 150% because she had 50% more candy than Erin. Erin bought 8 more candies, so we're going to call that 100%. So Sasha now only has 20% more than her. How many candies did Erin have at first? Explain. So Erin is here. Okay, each bar in the after tape diagram is 8 candies. So this is 8, this is 8, this is 8, and this is 8, and it lines up with this 100 here. So that is going to be 16, these two, and these two are going to be 16. So how many candies did Erin have at first? 32. Is that right? Each bar in the after tape diagram is 8 candies. So let me go back down here. Each bar is 8 candies. So this is 8, this is 8, this is 8, and this is 8, and this is 8, and this is 8. 1, 2, 3, 4, 5, 6. 8 times 6 is 48 candies. 1, 2, 3, 4, 5 is 40 candies. This would be 32, and this would be 40 as well. Because that Sasha did not change the amount of candy she had. That makes sense? So these are each 16 because they're the length of 2 of these, which were 8 plus 8 to get 16. 16, 16. 32, that'd be 48, not 40. So 48 did not change. Sasha's candy amount did not change. Erin increased hers from 32 to 40. So how many candies did Erin have at first? The answer is 32. Example 3. Kimberly and Mike have an equal amount of money. After Kimberly spent $50 and Mike spent $25, Mike's money is 50% more than Kimberly's. How much did Kimberly and Mike have at first? Okay, so now it says to use an equation to solve the problem. So let x be, so we not have to assign a variable. Let x equal Kimberly's money. After spending 50. Okay, because it says here, Kimberly and Mike have an equal amount of money. After Kimberly spent $50 will be our x. And Mike spent 25. Mike's money is 50% more than Kimberly's. How much did Kimberly and Mike have at first? So if we let x be the amount of Kimberly's money in dollars after she spent $50. After Mike spent 25, his money is 50% more than Kimberly's. So Mike's money is also $25 more than Kimberly's. So 0.5x, 50% of Kimberly's money. After Kimberly spent $50, Mike's money is 50% more than Kimberly's. So 50% of Kimberly's money would equal Mike's money, which is $25. So when I divide both sides by 0.5, that 50%, then these cancel, and I get the amount of money Kimberly had after spending 50, which is 25 divided by 0.5, which is 50. So Kimberly started with $100 because she spent 50. So use an equation to solve how much money did Kimberly and Mike have at first. So Kimberly had $50 plus the 50 she spent. So she started with $100. And Mike has $75 because he spent 20. His money is 50% more than Kimberly's after spending 25. Mike has 50 or 75 because 1.5, 50% more than Kimberly. Kimberly's 100%. 150% is 1.5 as a decimal representation. 1.5 of 50, Kimberly's money before or after she spent 50, equals $75. So they each started with $100. She spent 50 and now only has 50, and Mike spent 25 and now he only has 75. So using a visual model, like we did in the first two problems, we want to determine how many squares we're going to use. So we're talking about two people, and the percentage is 50%, 100%, 150%. So here's our first visual model, and this will be our after. So this is Kim, and this is Mike. So we have 0%, 50%, 75%, 100%, and we went out to 125%. Why? Is this right? Or do we want to... This is the before. This is before, not after. This is our before. Okay, just one second. Okay, so I just fixed this up. After is going to be on top. This is Kimberly, and this is Mike. So 0%, 50%, 100%, 150%. Because it says Mike's money is 50% more than Kimberly, so Kimberly is going to be 100%. So then I would shade in 2 of those. So in doing this, I would shade in 2 of those. That is Kimberly's money. And Mike's money is 150%. Because it's 50% more than hers. So she's starting with 100% value or amount of money, and he's got 50% more than her. So that's the after. After Kimberly spent 50, his money is 50% more than her. How much did Kimberly and Mike have at first? So now we're doing the before. Well, it's going to be, notice how these lines line up. This table has to line up. So now Kimberly has this amount still. And Mike has that still. Okay, it says after Kimberly spent $50 and Mike spent $25, Mike's money is 50% more than Kimberly's. So if they spent if it's $25 after Mike spent 25, so Mike's money was 150, so Mike spent $25, so now he's lost this square here, so he spent $25. So since he spent $25, this is what he had before. Spent 25, now he has this amount. So if these are all $25 squares, then each bar is $25. They both started with $100. Now he has $75 and she has $50. So it says after Kimberly spent 50, so she had 100, she spent 50, dropped it back to here. That's $50. After Kimberly spent 50, Mike spent 25. His money is 50% more than hers. So 75 is 50% more than $50. That's supposed to be dollars here. Okay, which method do you prefer and why? I'm not going to answer that for you. I prefer the algebraic version. I prefer to just use an equation and say 50% of some value equals 25 and solve for that value. Much easier, I think, than drawing a diagram, but that's up to you. So exercise. Todd has 250% more video games than Jalen. So Jalen has 100% of the video games, yes? Todd has 250% more. So let me color code these. Todd has 56 video games, which is 250% more than Jalen. He gives Jalen 8 of his games. How many video games did Todd and Jalen have at the beginning, and how many do they have now? Okay, I will do the algebraic version first. Okay, so we're talking about games. So let G equal number of video games that Jalen has at the beginning. Okay, G is the number of video games Jalen has at the beginning. That's this amount here. So let G be the number of video games. Then Todd started with 350G. So if Jalen has 100%, Todd has 250%. 100 plus 250 is 350%, which represented, so 350% is equivalent to 3.5 as a decimal. So we would say 3.5 G equals 56. To solve for G, we divide by 3.5, divide by 3.5. 3.5's cancel, and I figure out how much or how many video games Jalen had at the beginning. So 56 divided by 3.5. And I'll do it long division. Bring the decimal over 1, so I'll add 1, and it's going there. 35 goes into 56 once, subtract. 35 goes into 210 4 times. No, 6 times. 6 times. 35 and 35 is 70. That's 2 times 3 is 21. Yeah, 6 times. 6 times 5 is 30. 6 times 3 is 18, plus 3 is 21. And there's no remainder, so it's 16. So how many video games did Todd and Jalen have in the beginning? So G is the number of video games Jalen had. So this is Jalen. Todd had how many? 56. Todd has 56 games in his collection. How many do they have now? Okay, well, he gives Jalen 8. So now Jalen has 8 more. So now G plus 8 equals some amount, and we know that the G is 16, and that is 24. So now Jalen has 24 games. Todd gave away 8. That'll drop him down to 48 games. So they now have 48 and 24 games. Okay, that is the end of lesson 9. Review the lesson summary and go do your problem set.